All right, we are into lecture 4 of our segment on scientific realism, anti-realism debate. Um, we've seen the no miracles argument for realism. We've seen Larry Loudon's pessimistic meta-induction that aims to undermine that argument. But we haven't yet seen sort of a positive anti-realist view yet. Um, and most philosophers of science aren't anti-realists in sort of the sense, like nobody says, oh yeah, science is just bunk, it's useless, doesn't do anything, right? Um, Again, all of the philosophers in the segment, they are all accept and are impressed by the success of science, right? And they are worried about this tension that Loudon points out, which is that um, all of our past theories in some way or another have turned out to be false, and we have good reason to think that there will soon be better theories that will show that our current theories are false, right? So, um, in what sense can we be realists? In what sense can we say that science is getting it right? Um, and so, right today we're going to look at constructive empiricism. Von Frossen is the name associated with this, and a relatively short lecture and a bit abstract. I always know that I'm dealing with a very abstract subject when I can't really come up with any like pictures to go with the slides, so it's a little wordy on the slides. Um, but thankfully, it's not too long. I think hopefully you can get the idea, um, at the very least enough to sort of make your way through the quiz. There'll probably be one question on the quiz about it, and if it does spark your interest, then I can direct you to more stuff about this subject. So, in order to define his anti-realist approach, right? So von Frossen is an anti-realist, um, but again, not of the sort of coarse kind that just says science is garbage, right? He's the kind of anti-realist that wants to help us accept um, everything that's good about science. So he wants to define scientific realism so that he can then define his anti-realist account, right? In as a non-realist account. Okay, so according to von Frossen, realism has two components. So a realist takes a stand on what a scientific theory is, right? What it's supposed to be, and then also sort of what it does. And here is von Frossen's definition of realism. Science aims to give us, in its theories, one, a literally true story of what the world is like, and B, acceptance of a scientific theory for the realist involves the belief that it is true, right? So he's saying there's two things you need to be a realist. One, you have to have a belief of what it is that scientists are aiming to do with their theories, right? Or what science is supposed to be doing. And then the other is, what does it mean when I say I accept a theory, right? And he's going to differ from the realist on these 2 points. Again, for the realist, they're saying what science does is give us literally true statements about the world. And B, for a realist, when I accept scientific theory, I'm saying I believe that theory is true. Full stop. Okay, so let's talk a little bit about these two parts. So the first part, what does it mean to say that science aims to give us a literally truth story of what the world is like? Um, so this is different than talking about the aim, like the motive, right, of any individual scientist. Their aim might be to impress their mother or to make money. There's not a ton of money in science. I guess it depends on what you're studying, um, right, or just out for the fame or whatever. That's not what we mean when we say what is the aim of science, right? Um, what he means by the aim is like what counts as succeeding, right? What counts as doing your job when you're doing science. Um, and then when he says that, right, what counts as success in science is to produce a literally true story of what the world is like. Um, that literally part, right, conjoined with the true, is meant to contrast with logical empiricism or logical positivism, which we saw um, in our first lecture. And if you'll recall, Carnap and the logical positivists they did believe that scientific theories are true, but they said uh, when scientists say electron, right, what they really mean is something observable, right? A track in a cloud chamber, something like that. When a scientist says acidity, right, what they really mean is something like turns litmus paper pink. So, so logical empiricists think that science is true, right? Scientific theories are true, but not literally. Um, so von Frosten would not categorize logical empiricists as realists, right? To be a realist, you have to think that the theory is literally true. So when they say electrons, they mean a particle out there, right? That you can't observe and it exists. Okay, what is the second part? Um, so acceptance of scientific theory, right? Well, what does that entail when I say, I accept our current theories of sort of quantum mechanics, I accept uh, the the theory of evolution, right? What does that mean? So for von Frosten, uh, acceptance means just the belief that it's true, right? Um, so if I accept for the realist, right? So if I accept that our current physics is true, that means that I actually believe there are quarks and leptons and bosons and all the things that they talk about in their theory, right? Um, which should be straightforward, right? There's nothing tricky about this concept of what realism is. Um, the only problem is we have seen uh, this is sort of risky because theories change over time. Even the substances that they posit change over time. We've seen caloric, we've decided doesn't exist. Phlogiston, we've decided doesn't exist. So if you're a realist, according to von Frosten, that means you are sort of taking a leap and saying, I think we've nailed it, right? I think we've got it. I think our current theory and the particles that they posit are the ones that are out there, right? They're not going to discover any new ones later. They're not going to realize that a boson is actually sort of two different particles, right? Anything like that. So that is risky, right? And this has been the problem with realism as we've seen it throughout. And this is why one reason von Frosten is going to not want to commit to that. Okay, so von Frosten's view on science then is he calls constructive empiricism, right? So, like the logical empiricist, he is not a realist, right? He doesn't think that the theories are literally true. Um, so, what does that mean then? He's going to differ, right, from realism. Those two main points that uh, determine whether you're a realist. He's going to differ on both those points. And so, his definition of constructive empiricism is science aims to give us theories which are empirically adequate, right? Not literally true, empirically adequate. And then accepting a theory involves belief only that it is empirically adequate. Again, not belief that it is true, belief that it is empirically adequate. Okay, and we'll get into what that means to be empirically adequate. Um, so differs from realism on both points, right? So he's going to deny that the aim of science is to produce theories that are literally true. Um, and again, this is different than individual scientists probably do believe that their theories are literally true, but he's saying that's not the aim of science writ large, right? Um, and again, he's not making the same move as the logical empiricist. He's not saying it's true, but not literally, where if you translate it, it could be true. Um, no, he's not saying that at all. He's saying, um, yeah, when you're a scientist, right, you putting forward theories and you think they're true, but the aim of science taken as a bigger entity, right, that aim is not true, right? And again, by aim, we said what counts as success. So von Frosten is saying, um, the goal of science is to produce empirically adequate theories, not necessarily true theories. Um, and to be empirically adequate is to produce true predictions, right? That's what empirical adequacy is. Um, to produce predictions in the observable world, right? So I can say, so even if I talk about unobservable objects, right, like subatomic particles, I can make predictions about what you will observe under certain circumstances. And if I'm doing science right, those predictions will be true. So empirical adequacy, again, here's a formal definition, right? Theory is empirically adequate if and only if what it says about the observable things and events in this world are true. So it can say whatever it likes about the stuff that are not observable. That doesn't count towards empirical adequacy. Empirical adequacy tells us what we're going to see under certain circumstances. Right? Um, and notice observable, right? Not observed. So we're talking about things that haven't been observed yet, things that were never observed in the past, right? So it's much grander than just like it's not empirical adequacy is not making a statement just about observations, but about every possible observation. And then acceptance, right? So remember, von Frosten says constructive empiricists claim that accepting a theory only involves believing that it's empirically adequate, right? Not necessarily that it's true. So what is acceptance? Well, acceptance definitely means believing, right, in the empirical adequacy of a theory, but there's a bit more to it than just that. Um, so most of our theories currently, right, are not complete. They're going to be improved, right? So what you're really committing to is a research program, right? And when we next week we're going to talk about the concept of a paradigm, but I think there's a similarity between a research program and a paradigm, right? But broadly speaking, a research program is like the framework in which we think about how to solve problems in a given discipline. So we can think, we've talked a lot about the distinction between Newtonian mechanics and relativity theory. Those are both research programs. So according to Newton, right, when everyone basically accepted Newtonian mechanics, they're all committed to a research program that saw mass as constant, saw time and space as constant, right? And then we get Einstein, and now we have a whole new research program in which everyone is committed to a new set of assumptions, which is that mass changes the faster you go, right? That time slows down the faster you go. That time and space are uh, sort of linked in this thing called space-time that can be warped by very massive objects and stuff like that. So a research program in a way is a sort of a framework or a set of assumptions that everyone agrees on, right? They're sort of the rules of the game for solving certain problems in science. So if you accept, right, a current theory is true and you're a constructive empiricist, that's a lot. Even if you don't believe it's literally true, you are committing yourself to this research program, to this way of tackling the problems. You can think of it sort of like a belief system, right? So if I'm a Catholic, right, there's going to be certain limits, certain constraints on how I view the world, the acceptable solutions I see to certain problems in my life and things that aren't acceptable, or if have a particular political persuasion like a libertarian or a communist or something like that. So acceptance is a little bit more like converting to Catholicism, right, than just saying, oh yeah, I think quantum mechanics is probably right. Right? It's a substantial commitment. Okay, so observability, right, is an important concept for von Frosten because constructive empiricism says, um, right, the aim of science is to give us empirically adequate theories, and acceptance of a theory is only acceptance that is empirically adequate, right? And then we saw that empirical adequacy means it makes the right predictions about the observable world. So what is the observable world, right? What is observable? Some stuff is obviously observable. So, right, the shoes on my feet, uh, right, the table before me, obviously observable. But of course, in science, we often use instruments to observe. So I'm looking through a telescope and I see a moon of Jupiter. Is that observable? Does it have to be observable with the naked eye? Um, von Frosten says no, right? You can use a telescope, but a track in a cloud chamber does not count as observing an electron, right? You're seeing a cloud chamber, that the cloud and the track, those are all observable, but you didn't see an electron. You didn't observe that. So that's sort of where he draws the line, roughly. I didn't get too deeply into sort of his definition of observability, um, but that's the rough distinction. Um, And one other sort of interesting question you might think is like, well, that seems to hinge on just the the perceptual apparatus that humans happen to have, right? So, what if I was an X person, right, a Marvel character who could all of a sudden see right infrared radiation like a snake or something. Um, Von Frosten says, when I say observable, I just mean like the stuff we have now, not the stuff that we sort of perceptual apparatus we could have in a sci-fi story. Um, but that does mean if humans evolve, right, and all we do somehow in a million years to develop new perceptual capabilities, then that just means that the definition of observable will change, which is fine, right? Science will evolve as we evolve, right, and we'll presumably know more when we can observe more. Okay, so that is constructive empiricism, right? Fairly straightforward, just a few conceptual distinctions, um, and sort of a step back from full-throated acceptance of the truth of a theory, just saying, as long as it predicts the right stuff, predicts all the right observable stuff, then that's all I need, right? And it's not realism, but it's plenty good for uh, believing in science and the success of science and even working in science. So von Frosten thinks. Um, Now recall sort of the theme that Staley sort of introduced as a good example of the sort of theoretical posits that it's really hard to say whether they're real or not, right? And whether the our theories that talk about them are literally true or not, this sea of negative energy. Um, Remember the initial reason, right, why he posited it was that it made the math work out so beautifully. It seemed to simplify and unify quantum mechanics and relativity. Um, and we saw this notion of simplicity and strength also in Lewis's account of laws, right? Um, and often philosophers and scientists are really drawn to this notion of simplicity and strength, and they tend to favor a theory that has those virtues over theories that don't. Um, but notice that none of that is an observable consequence of the theory, right? That is just sort of the beauty of the theory in the abstract. So von Frossen is not going to count those, right, towards theoretical acceptance, right? The more simple theory to him has nothing else no more going for it than a really complicated theory if it gives us the same predictions in the observable world. So what that means is if you're a constructive empiricist, you're going to be open to a lot more theories, right? You can have multiple theories that give you the same observable predictions. Um, and if you don't have any other reason to judge why one is better than the other, then you just kind of have to accept all of them. And von Frosten just sort of bites that bullet and says, yeah, well, that's fine. Um, but he thinks that where the rubber hits the road, right, everyone agrees that if your theory makes the wrong predictions when it comes to observable phenomenon, then it's probably bad, right? Um, and the ones that do make the right predictions, we keep them in the mix. So he thinks where it counts, right, constructive empiricism is not going to be like revisionary um, with regard to scientific practice, right? It's going to agree with the scientists on most things when it really counts. Um, and it saves us again, the problems that Loudon points out, where it's just not clear that we can accept that our current scientific theories are like literally true, where every particle they talk about will, at the end of history, be proven to actually exist, right? We just don't know. And it seems like um, history of science shows us that it will probably be revised over and over. And some of the stuff we talk about existing now in our theories will turn out not to exist, right? And so von Frosten says, if you're a constructive empiricist, that's fine, right? All you were committed to was the observable. Okay, so one more lecture for this week. It'll be on scientific realism. I'm sorry, it'll be on structural realism, which is a form of scientific realism that tries to have, as Worrell says, the best of both worlds.